October 13, 2025, 6:23 p.m. Central Time. Ship 38 and Booster 15-2 roared off the pad at Starbase, Texas, marking the end of an era. This wasn't just another Starship test flight. It was the swan song for Block 2, the final launch from Pad 1 in its current configuration, and the closing chapter of one of the most turbulent years in SpaceX history. 2025 was supposed to be Starship's breakthrough year. Instead, it became a year of explosions, setbacks, and hard lessons. 4 Block 2 ships failed catastrophically. 1 didn't even make it to the pad. The program faced its darkest moments since the early test campaigns, but Flight 11 changed everything. Welcome back. I'm Christopher, and today we're breaking down why SpaceX is retiring the entire Block 2 Starship generation after just 11 flights, what made S38's final mission so significant, and what Block 3 promises to deliver. This is the story of how SpaceX is moving forward by leaving behind an entire generation of hardware. By the end of this video, you'll understand why Block 2 had to end, what went wrong this year, how Flight 11 redeemed the design, and why SpaceX's rapid iteration strategy means retiring good enough hardware to pursue revolutionary. Let's dive in. To understand why Block 2 is being retired, we need to talk about 2025. A year that tested SpaceX's rapid iteration philosophy to its absolute limits. Block 2 of the Starship upper stage had what can only be described as a checkered past. Ships 33, 34, 35, and 36 all suffered failures in different ways, and Ship 36 didn't even make it to flight. 4 catastrophic failures in a single year. That's not just bad luck, that's a systemic issue. Each failure had different root causes. Some involved engine failures during ascent. Others suffered problems during the coast phase. Ship 37 on Flight 10 even experienced an explosion in the engine chill lines caused by ice blockage that ignited from static discharge. A problem so specific, it shows how complex these systems are. But here's what's fascinating about SpaceX's approach. They didn't stop. They dissected these anomalies, found different root causes for each, and made several improvements ahead of Flight 10 in late August. The rapid iteration philosophy means learning from each failure and immediately implementing fixes. Block 2 boosters, by contrast, performed nearly flawlessly. Boosters 14, 15, and 16 all completed their mission successfully. Booster 14 was even reflown, and Booster 15 would fly twice, once on Flight 8, and then again as Booster 15-2 on Flight 11. The super heavy side of Block 2 was a complete success. This split performance reveals something critical. Block 2 was an interim design intended to increase reliability and get Starship into orbit, but the upper stage design had fundamental limitations that kept causing problems. Ship 37 on Flight 10 finally broke the curse with a successful mission, proving the fixes worked. But by then, SpaceX had already decided to move on. So what exactly defined Block 2? Why create an entire generation of hardware just to retire it after less than a year of operations? Block 2 was always an interim block. It had reduced payload capacity and wouldn't be capable of in-orbit refueling, the critical technology SpaceX needs for lunar missions and Mars colonization. Think of Block 2 as a learning platform, not the operational vehicle. The Block 2 design incorporated lessons from Block 1's earlier flights, but with significant constraints. It couldn't deploy operational Starlinks as originally planned. It lacked the systems needed for orbital operations. It was designed for suborbital testing, getting to space, proving re-entry, and demonstrating landing. Key Block 2 improvements over Block 1 included refined heat shield tile application, upgraded flight software, improved engine reliability, and the hot staging system that separated the ship from the booster while engines were still firing. These weren't small changes, they were fundamental improvements to the entire vehicle. But Block 2 ships still used earlier Raptor engine variants, not the advanced Raptor 3 that will power Block 3. They had the original payload bay design without the improvements coming in the next generation. They were limited to 6 Raptor engines instead of the 9 planned for later variants. Essentially, Block 2 was the good enough to test version, not the good enough to operate version. And in SpaceX's development philosophy, once you've learned what you need from a generation, you move on, even if that generation is still working. October 13, 2025, SpaceX gave Block 2 the send-off it deserved. Flight 11 was in the best possible way, boring. And in rocket development, boring means successful. Booster 15-2 and Ship 38 lifted off at 6:23:45 p.m. from Pad 1 at Starbase. All 33 engines were running at liftoff, and unlike Flight 10, no engines shut off during the ascent. This was already an improvement, full power all the way to staging. For the last time with this configuration, hot staging was completed flawlessly. The system introduced between Flights 1 and 2 had proven itself repeatedly. Booster 15-2 then executed its boost back burn with only one minor issue. A single Raptor failed to relight, but the remaining engines compensated perfectly. Here's where things got interesting. Instead of attempting a tower catch, Booster 15-2 conducted landing burn experiments testing configurations planned for Block 3. The booster completed a simulated catch hovering above the Gulf of Mexico on 3 engines before intentionally cutting power and crashing into the water. Why destroy a perfectly good booster? 2 reasons. First, to prevent it from floating into Mexican waters and creating international incidents. Second, because the data from those landing tests were more valuable than catching a booster they were retiring anyway. Meanwhile, Ship 38 was writing its own success story. After a perfect ascent, it deployed dummy Starlink satellites, continuing to validate the payload deployment system. Then came the critical in-space burn test. For the 3rd time in the program, SpaceX successfully relit a center Raptor engine in space. This capability is crucial for controlled deorbit. When ships eventually reach orbit, SpaceX needs confidence that they can bring them down safely in controlled locations, not randomly crashing wherever orbital decay takes them. Then came re-entry, the moment that had destroyed so many Block 2 ships. SpaceX deliberately removed heat shield tiles from areas without backup ablative material, pushing the limits to understand failure modes, and Ship 38 survived beautifully. During re-entry, Ship 38 performed S-turns similar to space shuttle maneuvers to bleed off speed. At 52 kilometers altitude, while still traveling at 15,000 kilometers per hour, it executed a dynamic banking maneuver, a banking turn, simulating the final approach for a tower catch at Pad 2. This was airplane-like maneuvering at hypersonic speeds, one of the most impressive demonstrations of Starship's capabilities yet. Ship 38 then completed the belly flop maneuver, executed the flip and burn, and splashed down precisely on target in the Indian Ocean. Block 2 ended on a high note. After 4 catastrophic failures, Ships 37 and 38 proved the design could work when everything came together. So if Block 2 was finally working, why retire it? Because working isn't the same as capable of the mission. Block 2 was never designed to be the operational Starship. It had fundamental limitations that would prevent it from achieving SpaceX's actual goals. Most critically, it lacked an in-orbit refueling capability, the absolute cornerstone of SpaceX's lunar and Mars architecture. NASA's Artemis program requires Starship to land humans on the moon. That mission demands orbital refueling, launching multiple Starship tankers to fill a lunar Starship's tanks in Earth orbit before it heads to the moon. Block 2 physically cannot do this. The plumbing, the systems, the propellant management hardware, none of it exists in Block 2. Block 2 also had reduced payload capacity compared to what's planned for Block 3 and beyond. While exact numbers remain classified, industry estimates suggest Block 2 could deliver roughly 100 to 150 tons to low Earth orbit, while Block 3 aims for 200-plus tons with refueling, enabling much more ambitious missions. Additionally, Block 2 used earlier Raptor engine variants with less thrust and efficiency than Raptor 3. The ship design had limitations in thermal protection, propellant management, and structural capacity. Every subsystem was good enough to test, but not good enough to scale. SpaceX's philosophy is clear. Once you've validated course concepts, don't waste time perfecting an interim design. Move on to the next generation that can actually accomplish operational missions. Block 2 taught SpaceX how to fly Starships reliably. Now, Block 3 will teach them how to fly it operationally. So what makes Block 3 different? Why is this the generation SpaceX has been building toward? First, Raptor 3 engines. These represent a complete redesign with higher thrust, better efficiency, improved reliability, and simpler manufacturing. Early reports suggest Raptor 3 produces over 250 tons of thrust at sea level, a significant jump over earlier variants. Block 3 ships will be larger than Block 2 with increased propellant capacity and payload volume. More importantly, they have the systems necessary for orbital refueling, propellant transfer connections, tank pressure management, cryogenic fluid handling, and the avionics to coordinate complex docking and fuel transfer operations. SpaceX has already confirmed that Booster 18 and Ship 39 will be the first Block 3 vehicles. Booster 18 currently has a fully stacked liquid oxygen tank with the liquid methane tank stacking in progress. Ship 39's nose cone, and payload bay recently rolled to Mega Bay 3. These vehicles will launch from Pad 2, a completely redesigned launch facility with improved propellant loading, better lightning protection, enhanced water deluge systems, and infrastructure designed from the start for rapid reusability rather than being retrofitted. Elon Musk stated in a May 2025 speech to employees that it takes 3 major iterations of any new technology to have it really work well, and that Block 3 should be rapidly reusable with orbital refueling capability. If those promises hold, Block 3 will represent a transition from development to operations. The retirement of Block 2 marks a critical inflection point for Starship. We're moving from can we make it fly to can we make it useful. Block 3's first flight is expected in late 2025 or early 2026. SpaceX will use these vehicles for the first true orbital flights, not just suborbital trajectories. That means completing full orbits of Earth, demonstrating long-duration spaceflight, and validating systems in the actual environments they're designed for. Next comes operational payload missions. SpaceX needs to prove Block 3 can reliably deploy Starlink satellites, potentially launching hundreds at a time compared to the 60 carried by Falcon 9. This would dramatically reduce the cost per satellite and accelerate Starlink network expansion. Then the big one, propellant transfer demonstrations. NASA requires SpaceX to prove orbital refueling before committing to using Starship for Artemis lunar landings. Multiple tanker launches would rendezvous with a depot Starship, transferring hundreds of tons of propellant in orbit, something never attempted at this scale. Artemis 3, the first crewed lunar landing since Apollo 17 in 1972, originally targeted 2024, then slipped to 2026, and now looks more realistic for 2027 or beyond. SpaceX needs to demonstrate reliable Starship operations, successful orbital refueling, and lunar landing capabilities before NASA commits astronauts. Beyond the moon lies Mars. Elon Musk's ultimate goal remains establishing a self-sustaining city on Mars, with Starship as the transportation system. But that vision requires not just Block 3 working, but potentially Block 4, 5, and beyond as SpaceX continues iterating toward a truly rapidly reusable interplanetary transport. Ship 38's last flight on October 13, 2025 closed the chapter on Block 2 Starship. After a tumultuous year with 4 failures, the final 2 Block 2 ships, Ships 37 and 38, redeemed the design with flawless missions that validated core concepts. But validation isn't the goal, operations are. Block 2 taught SpaceX how to fly Starship, how to survive re-entry, how to deploy payloads, and how to push systems to their limits. Now, that knowledge gets applied to Block 3, the generation designed from the start for rapid reusability, orbital refueling, and the operational missions that will actually change spaceflight. If you found this deep dive in S38's final flight and Block 2's retirement valuable, make sure to like this video and subscribe for more SpaceX and spaceflight content. What are you most excited to see from Block 3? Let me know in the comments below. Block 2 is done. Long live Block 3. Thanks for watching.